Hello, welcome back to my channel. So this is the part 1 of the building a CAN bus log viewer using Rust, SQLite and EGY. In this part we are going to use a data layer, a struct to represent the CAN frame and functions and to create a database, insert frames and query into them. So in this video you won't see a GUI, GUI will be the part of the next video. Before writing code, we will basically create our new project and I will explain you the directory structure. So let's get into it. So what we do is that we create our new project, cargo, new, can underscore log underscore db, and then we press enter. So this will create our new project, which is here. And you know the simple repository structure, which is already being created. Let's go into our project. So we do cd can log db and we are into our project. First, we need to add few things to our cargo.toml as usual. So what dependencies we have? Here we have an important dependency to Rust SQLite package, which comes like this. rusqlite equal to, and then we can have version here. And version will be, the version we are using is 0.31. So if you're following this video, please make sure that you use the correct version. Otherwise there could be problem because sometimes the features sometimes the features and their syntaxes are a bit different between the different version. So here we are going to use this version. So please continue with the same version. Okay, so we are going to use a feature called bundled here so that we get everything what we need. So this is our simple cargo.tom. Now the bundled feature which we have written here basically compiles the SQLite directly into a binary. So viewers don't need to install a SQLite separately. So you don't need to install SQLite as a software. It will just basically it will do it for you, and this avoids a common beginner stumbling block, like you don't need to. So it just make it simple, so you can follow the same step what I'm doing right now and you don't need to do anything extra. So the first class that we need to create is called model.rs. So we are going to create a class called model.rs, and here we are going to define our first structure. So how do you are going to define it? So the first thing we are going to do is write our derive, and this derive is basically written, I'm not going to use clone, I'm just going to use derive. So once I write this whole structure, then I can explain you field by field, but first I would like to write. So okay, so I like struct, and how does a CanFrame looks like. So if you are familiar with automotive, you might already know it a bit, but if you're not familiar with automotive, this is the example I took because I work in automotive industry, so you don't need to worry about it. So first we take id as option U832, or actually I would go for I64 here. Then we will take the timestamp which is not I64, which should be float 64 here because it can be represented in decimal as well. And then I'm going to take an arbitration ID. I will just explain in a bit what is arbitration ID is. You don't need to worry about that. So arbitration arbitration ID, which can be to see. Then we take our public DLC. So DLC stands for data length code, which will be uint8, and then our actual data, which is basically let's not take a vector here. So what I will do is that instead of that I will do something like this. Okay, so this is a vector. So let me first explain you step by step. So the first basically is ID. Every SQLite row has an auto incrementing integer ID. We wrap it in option because CanFrame we just built in Rust doesn't have an ID yet. Only after SQLite insert it gets one. So this is a very common Rust pattern. This value might not exist, so we don't need to insert it. It will automatically be generated once the CanFrame gets inserted into the database. The second is the timestamp. So we are basically using float here, like 0.002341 seconds since the log started. So F64 gives you enough precision basically. Then is the arbitration ID. This is actually the CAN message identifier. We are using uint32 because extended CAN IDs can also use 29 bits, which doesn't fit a 16-bit integer. DLC is our data length code, always 0 to 8. So a U8 is between 0 to 255, more than enough, and it's natural a small non-negative number type in Rust. Then the data, which I defined in square brackets between U8, 8 and 8. So CanFrame carry at most 8 bytes of payload. This is a fixed size integer, not a vector. So we always know that the max size at the compile time, so we avoid heap allocation entirely, and that's why the reason we didn't use the vec. You might be wondering about the derived debug, basically which let us print the CanFrame directly. So for quick debugging, so you will use this constantly while testing. So make sure whenever you write test chunks, use the derive. Now we are going to create a database, and in this particular project you will see that we are creating different files for it, and we are not writing everything in the same file. And this is actually happens when you write a production code, you don't write everything in the same file. So here we are going to use our SQLite, and we are going to use the connection and the result. So we don't need to use the parameters here, we just want to use the connection and the result, and we press enter. So okay, now we create our first public function here, which is initDB, and initDB is going to take a connection and basically going to result as a connection as well. I will explain you a bit why the result is in between the connection and why it is taking a connection, but don't worry about it. So the first step our function wants to do is let con equal to connection.open, and this is something. So remember that we are taking this connection, so we are not taking a connection actually here. We should take, oh yeah, that's why it was showing wrong. So we shouldn't take a connection here. We are going to take a path, which is basically a reference of str. Okay, and here instead of this we are going to pass, and this question mark you already know basically is because of the error. Then we are going to go execute, create table. If not exists, we can say CanFrame or frames. Then we are going to do ID, timestamp, arbitration ID, then DLC, which is data length code, and data. And then we are going to close this here, and here we don't need to pass this. We are going to pass this, and then this, and then we are going to say okay connection, and instead of here we should pass connection here. So I'm going to accept it. Okay, so now what we have done is there we have created a database. Now just let me explain you line by line. The first line which you see here is called the initDB, which takes a file path, like for example the candb, which will be passing here in the main function, returns either a working connection or an error. That's why the result is for. So our SQLite result is just, and basically it will give you a connection or an error under the hood. Connection.opens or create, if it doesn't exist, a SQLite file at that path, and the question mark means that if this fails, stop the function right here and return the error immediately. So Rust short circuits error handling and emphasizes this on the question mark pattern. Con.execute basically runs a raw SQL that doesn't return rows, so basically just runs a raw command. And I think data.blob is basically, that's why this is for. So basically it will take the second, this is basically the second argument to execute. Normally this is where you pass the query parameters, place order like question mark 1, question mark 2. Here they are none, so it's fine right now because we are just creating the table, we are not inserting anything. And then OK connection is basically returning the connection wrapped in OK, since the function returns a type result, and we are not going to put a question mark here because this is our return. Now we are going to create one more public function here, which is basically the insert function here. And you see why I'm writing public here everywhere, because so that I can use this function in a different file. Now insert CanFrame can take a connection and a frame. Here frame would be just a CanFrame, means I know it has written super, but we can also write small CanFrame and this would also work. Okay. Yeah, so it says that I should use this because I'm going to use the model and the CanFrame. That's fine. Okay, sorry, I think I miswrote something. I'm just going to save this one and go back. Now what we are going to do here is that same thing, result can be anything here, and we are going to use a con.execute and insert into basically frames. Why I'm written CanFrame here? Okay, so remember the table name, you can choose whatever you want. So you can choose CanFrame here, or you can also choose frame here, but it should be same. So the table you created, the table you insert into. Pretty simple, right? And then you pass timestamp. As I told you, we don't pass the ID here because the ID is automatically created. We pass the other values what we want, and we pass $1, $2, and then we basically write the actual values what we want to pass in the second argument. That's what we were leaving it empty in the upper part. Okay, and now this is the same thing, error handling, and then we return okay. Here, I hope you are able to explain every line. If you still have doubts, you can write me in the comment section and I can explain more. Now, we go to the main.rs. Main.rs is basically where we bring everything together. Now, it might take some time, so you have to wait a bit. So I'm going to use mod db here, and then I'm going to use mod model here as well. Then use db, insert CanFrame, and use model CanFrames as well. So maybe I should also do, instead of this thing, I'm going to use model here and then use model.canFrame. So this is basically the correct way of doing it. Now we go back to our main.rs. Here we basically took everything we wanted to took, and then basically what does should main result. Remember that we were resulting the SQLite error, and that should also be written here as well. So we should do with rus SQLite result, and this is fine, and this is fine. Okay, now what we are going to do, we are going to say let connection equal to initDB, and you can give the DB name whatever you want. Now so we are going to insert some frame. You can create basic anything which can be ID equal to none, timestamp can be anything, interpretation ID is 0, 1, 2, 3, 4. Again, this is just a sample synthetic frame. It's no actual data. We just want to put something into our database. Now what we need to do is that we are going to call the insert frame, in which we pass the connection and the frame. Now here we already have a print, but what we can also do is that we can try to print our inserted frame, right? So this is what our we use the derive for the debug, right? Here if we go back, we use the derive debug, and this is how it will be used, so that it will actually print all the structure values here. Now what I'm going to do for the for our second video, which will help us, is not just inserting one frame. I'm going to just insert multiple frames so that we can actually see a plot in the GUI. So what I'm going to do is that I'm going to use for in, let's say 0 50, and then I'm going to this. No, I'm not going to do this. Or I can actually do this as well. So it doesn't matter how you basically create your CanFrame. You can just do anything which you want so that it comes up with a good value. And here basically to say 0, 1, 2, 3, 4, 5, 6, and it will be, and it's a synthetic frame, so whatever you can do. So the only thing which I need to explain you that this little loop is new, and this part one is basically, as I told you, is just to have a frame. So let me run this code because we are going to anyway modify this code. So just let me call cargo run so that we basically have the whole code, and let's see if it's working correctly or not, or if there are any errors. And if there are any errors, we can solve them. So it says that we haven't closed it correctly, and maybe this is correct. So let me see. Yes, so there's the extra bracket here, and let me run again. Models file not found in db.rs. That's strange. It should be able to find module models. Why it is not able to find here? Use mod models, main.rs, mod models. It's okay. Maybe it cannot be delivered like this, but that's strange. It should be able to use this. Let's work. Now unresolved create model now. or maybe I should use db. Where this model is defined? db.rs is using model. So okay, db.main is also using rs, and then basically I was basically solving it in the wrong path. So it says unresolved input model. This. Make sure that file model.rs. So I did some debugging to find what the actual issue is. So the only issue which was there is basically you just need to add this use create model here, and then you can switch it to this model.canFrame. In main.rs everything remains same, and in model.rs there is nothing. So if I just clear this for you and just run the cargo again, obviously there are some warnings which you can ignore, but you can say the inserted CanFrame is this. So now our code is working, and we will move to the video 2 for our GUI part. So please make sure you like and subscribe the channel, and see you there.